Hello 8th graders. We are now in section 8.4, which covers angles of elevation and depression. So what does that mean? Well, first off, pilots and air traffic controllers actually use this all the time when they calculate distances. An angle of elevation is the angle that is formed by a horizontal line, and a line of sight to a point above that line. So let's say this is the person. Hello, I am a person, and I am looking, and here's whatever I'm looking at's up here, a kite or whatever. This is the angle of elevation. So it says in the diagram, I haven't drawn a diagram yet, but I will. It will show you that elevation. The angle of depression is the angle formed by a horizontal line, and a line of sight below to an object. So here's someone looking down. This is called the angle of depression. So here would be the diagram that would show that. A horizontal line looking upward. Here's angle 1, which shows an angle of elevation. A plane with the horizontal line looking downward, this would be the angle of depression. Since horizontal lines are parallel, angle 1 and angle 2 by the alternate interior angles theorem are congruent. So, in the picture I just showed you, and let me actually bring it up again. In this picture, you can see, let me make it larger. You can see that horizontal lines, they have a slope of 0, so they're the same, they're parallel. Angle 1 and angle 2 in this case would be the exact same. Now, the angle of elevation from one point is congruent to the angle of depression from the other point. So if we look at this example, you don't need to write this one down. If we look at this example, we want to classify both angle 3 and angle 4 as an angle of elevation or angle of depression. The pictures that you're going to be using are going to get quite complex at some point. And so you're going to have angle measures all over the place. So you're going to have to be able to determine which one's which. So if you're looking at this, angle 3. Angle 3 would be what? It would be an angle of depression. And the reason is because you have a horizontal line from the plane and you have a point below it, so therefore you're looking down, it's angle of depression. Angle 4, here's your horizontal line, and you're looking up, a point above it, so angle 4 is an angle of elevation. So in example 2, we're going to find the distance. So here's our problem. An air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. The pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? Round to the nearest foot. I'll tell you right now, you have to. You have to draw a picture. It will help you so much by drawing a picture. So let's draw a picture. We know the plane, which is up here, it has an altitude of 4,000 feet. We want to find the horizontal distance, so I'm just going to call this x. And it has an elevation of 41 degrees. So let's figure this out. I have 41 degrees. What do I have based on that 41 degrees? I have the opposite side and the adjacent side. So that would be tangent. Tangent of 41 degrees equals opposite over adjacent. I want to solve for x, so I'm going to multiply both sides by x. That would give me x times the tangent of 41 degrees equals 4,000. Divide both sides by the tangent of 41 degrees. And I want to round my answer to the nearest foot. So the distance, which is x, represents approximately 4,601 feet. And that'd be my answer. In example 3, we're going to once again find the distance. So we have a forest ranger in a 90-foot observation tower that sees a fire. The angle of depression to the fire is 7 degrees. What is the horizontal distance between the tower and the fire? So we have a tower, and I'm going to call this T for tower. I know that's very original. And F for fire. We know the 90-foot tower, and we know the angle of depression is 7 degrees. Here is the biggest mistake you can make by putting the 7 degrees right here. Absolutely incorrect. This is not 7 degrees because we have no horizontal line. The horizontal line from the tower is here. The 7 degrees is here, which leads to something that a lot of students make a mistake of. The angle of depression may not be one of the angles in the triangle you are solving. It may be the complement of one of the angles in the triangle, which is the case here. So this angle is 7 degrees. Which actually doesn't matter because you may think to yourself, well, wait a minute, I don't have either of one of these angles. How can I use a trig ratio? You don't need them because I want to find x. So x would be a horizontal line. We want to know the horizontal distance between the tower and the fire. But here's what we should look at. This is x. This is what I want. Right here, the horizontal distance. We know this is horizontal. So that means if this is 7 degrees, this is also 7 degrees. Because why? Because they're alternate interior angles. So now what do I have? I want to find x. I have 7 degrees. I have the side across from it and the adjacent side. So I'm going to use tangent of 7 degrees equals opposite over adjacent. If I multiply by x and divide by tangent of 7 degrees, I would get x equals 90 divided by tangent of 7 degrees, which would give me a distance of approximately 733 feet rounded to the nearest foot. In our last example, example 4, a pilot flying at an altitude of 2 7/10 kilometers sights 2 control towers directly in front of her. The angle of depression to the base of one tower is 37 degrees. The angle of depression to the base of the other tower is 58 degrees. What is the distance between the 2 towers? Round to the nearest tenth of a kilometer. So if I draw this situation, we have a pilot. The pilot to the base of tower, let's say A. Now we always have to remember that horizontal line. We have tower A and we have tower B. So we have 2 triangles that are formed. Now in this case we have 2 angle measures for the angles of depression. Well, this one is going to have to be 37 degrees because it's smaller, and this one is going to be 58 degrees. So what I need to find is the distance between the towers. The distance between the towers is x. The first thing I have to do, though, is I have to figure out how far up the pilot is, which is 2.7 kilometers. We also know that because of alternate interior angles, this angle is 58 degrees, because this 2 horizontal lines, these 2 angles are alternate interior, and using these 2 lines in this transversal, PB, this angle right here, angle B, would be 37 degrees. So, the first step I need to find, I have to find this distance here. I'm going to mark this in green. That's y. I then also have to find this distance, which is going to be w, using the 37 degrees, and then I'm going to have to subtract to get my distance between the towers. So in green, let's start with y. Since I have 58 degrees, I have the opposite side and the adjacent side, so that means I'm going to use tangent. So tangent of 58 degrees equals 2.7 divided by y. If I multiply both sides by y and divide by tangent of 58 degrees, I'm going to get y equals 2.7 divided by tangent of 58 degrees. That gives me approximately. Now, I'm going to actually put a long decimal in here so I can get an accurate difference when I subtract them. So y is approximately 1.6871 kilometers. Now, to find w would be tangent of 37 degrees equals the opposite side divided by w, the side we need to find. This would give me w equals 2.7 divided by tangent of 37 degrees, which gives me approximately 3.583. Now I have to subtract the difference, which gives me x, and that means they are about 1.9 kilometers apart. If I subtract them and round to the nearest tenth of a kilometer, that would be my answer, approximately 1.9 kilometers. Your vocab words are angle of depression and angle of elevation.